Oakley, good evening, heroes and heroines, and welcome to Practising Programming and C, where we're just going to do a little bit of stuff, potentially the last bit of database manipulation stuff that we need to really do, except for the upgrade database. We still need to do that. But the stuff we're doing is the reorganization. Which should be pretty easy to do, actually. Shouldn't be too tough. But before we get onto that, I thought I'd just take a moment to, to address this. It's not really a big issue at all. But you can see that in both of these functions, we've got sync projects and we've got sync DB. They're essentially the same function. The sync DB one operates at the top level, so it's operating on project blocks. Well, the project block actually. In fact, yeah, that's exactly all it is. It's just operating on the project block level, whereas the sync project is operating on like DB header projects. Right. So you'll see that they're basically exactly the same. This definitely doesn't need to happen. That's just old news. So yeah, these two things are pretty similar. I think. What's all they saying? ensure they're in alignment. Update that if they've been reorganized. Do the stuff that syncdb with input does. Okay, yeah, don't think we're doing that. I think that just happens later on as a matter of course, I think. Well, the other one that's a given for each road is if it's correctly located the stored. Look to see if it's in one. It should be promoted if it is in one of those. Initialize new one, yeah. So we're doing that. So set the recursive function returning it to all the charts. So yeah, I think we're doing both of those. These two things we're actually doing, more or less. Essentially, you can sort of see that these guys are doing the same thing. The only difference being that they are operating. So we've got like on this side, there's like underscore top level. There's a few top level things, and all that means is that the parent that it's passing is of type DB block projects, whereas on the other side, where it's doing reorganized projects, the parent, the CI, is that right? No, probably the S. The S is a DB header project, yeah. But I'd like to draw your attention to this actual loop, right? I did mention it the other day actually, but you can see we're entering this loop. Then we're doing if this, do this stuff, then break. Otherwise, do this stuff and then break. Right? So, in both of our cases, when we enter this loop, we're breaking straight out of it. So we're never getting anywhere close to, like, we probably never do this, and we'll probably never evaluate this for a second time, I guess. Yeah, I suppose. So there's S child, and there's C child. So we are going to, well, we are kind of going to pull them off, aren't we? But I guess if this doesn't have a child, so I think we might have to do one test, which just is the CI less than the stored child count. I think we do need to do that test. Yeah, I don't think it'd be sufficient to just straight up dive straight into doing this without having checked to see if there is an actual stored child. So let's just do this. We're not looping. Yeah, unfortunately we still got this located boolean then, haven't we? Because what I was hoping to do was essentially yeah, it's essentially to do a test right on here. It was like I was hoping to be able to say, so there's gonna be no if. This is just gonna be the whole thing. I was hoping to be able to say else if we haven't reorganised the child, then go ahead and insert project into DB. Well, I don't think that's sufficient. I think you still need a way to actually handle a case when there's no child count. Which is a little bit unfortunate, but that's how it goes sometimes. So if we've got a child count, then you can try and see if they match. If they do match, then we have located it. Add entry to generation. Yeah, okay. If they don't match, then we try and reorganize. Right. Setting located if we have reorganized. If we get out of this whole thing, so whether the configured index is less than the stored child count, or rather if that is not less than the child count, meaning we don't enter this, we don't pass this test, or we haven't reorganized, then we do this insert project into DB. One thing I was also wondering was, should I change this person? So rather than returning the S child and having this outer person bother with these parent pointers, should I just make this take a pointer to the S child? Sorry, should I make this, well, this call pass the address of the S child in the same way that this guy is, and this guy. Yeah, it's possible we don't need to care about the project parent pointer actually. Yeah, I don't think anybody's going to be using this actual signpost. You know, everybody's just talking about figuring out where these people are, and then just fixed up the pointers themselves, rather than using the signpost to do it, which is perfectly fine by me, I think. So I might suggest that we don't bother with this. What is this S pos? Might change that to be S byte. Or should I change the other ones to be S parent pos? But it doesn't matter at all. So yeah, if we let that happen, we don't care about that initial S. S pos is going to be that. We don't care about the project pointer. What we do care about though, well, is this. Yeah, and it does seem that we do need to sort of talk about that each time through the loop, interestingly. The S. Well, I'll take that back actually. I don't think we do need to talk about it each time through the loop. Right. Because these people are taking the actual pointer to a pointer here. This person's dereferencing. But as I was sort of suggesting, we could make this person take the pointer to a pointer in the same way that this person is. Right. So every time through this loop, this thing should be positioned correctly. Without us having to set it here. Right. And we only care, well, we do care, yeah, we need to propagate this out to the outer function correctly. Let's try it. Let's just see what happens if we make it just happen out there. So it's saving off the location there, and just before it exits, it fixes that guy back up to be what it was at the beginning. I think that's reasonable. And then this dude here actually takes that and this. Right. hold on a second. What did I just change? So it's the S child. It's the void insertion point. Can you pass a void star? Maybe we don't need to play around with this. But it could be nice, couldn't it? If we make that take the pointer to a pointer so we can modify it. The postambule does the cycle signposted file. So if that is to take, yeah, I guess it's the person who's 12. Right, yeah, so car star, is that right? Car star for that, yeah, I think that's right. Then the postambule happens. So yeah, we just need to get this returning a DB header. And then having done the init project DB postambule, we do P. Blimey. And then we finally return the result. Oh, right. So that's supposed to be taking a project. Okay, fine. think that's okay. So we did that for here. For insert project into DB. Right, that was the one that we just changed, wasn't it? So we made that take the S directly, so it could modify the S. Right, in order that this should continue to work. So now let's do the similar thing on the other side for the insert project to DB top level. Right, let's take the address of the S parent, because in this case we're just pulling off the parent here. I think that's right. Oh yeah, right. So in it printed DB block. Yeah, I think we didn't need to care about this guy happening up there because it wasn't the actual thing we did with passing. I don't think. Yeah, it's supposed to be the actual P, not the parent. So yeah, I think that was just purely a sort of a correctness thing. Like, I don't think it was right. I don't think it was correct to be doing that sort of operation on this inside this loop. Essentially, is what that was all about. I think it's more correct to do that at the extremes. And you do also need to make sure that you're only actually doing this for stuff that is going to be in the same place. Which I'm reasonably sure that these guys are. But I guess we'll see when we get there, if they're not. But, yeah, we've done that. So we could change this to be S parent count, wasn't it? And then we don't need to break. But we are still needing to locate. And if we haven't located, then we do this. Yeah, it was the insertion point, wasn't it? Now, an interesting thing about this, actually, I've just realised that this isn't such a hard ship at all. If you can, if you're allowed to pass a point to a point, avoid star star. If you're allowed to do that, then we can just skip. We don't need to. All you do is you just don't return the result. You just set the insertion point to be the result of this, don't you? So let's just see if you can actually do that. I'm not sure if I've ever tried to do that before. Then you can get out of the business of having to bother about it outside the function. So you've got avoid star star insertion point. Yeah, it's a void function. Should be now. So it's passing it from incompatible pointer type. Ah. Expected to void star, but DB argument type. Oh. Yeah, okay, so you can't do that really. So that's answered the question, hasn't it? Now, we do happen to know, though, when we're inserting a product into DB top level, we're always passing an S child. So this might as well be a DB header project, mightn't it? Who else is using the insertion point? Is it DB pro? Is it product and DB preamble? I mean, whether or not this is taking a void star, which it is. Yeah, that's only caring about the insertion point. Oh right, yes. So we actually need to pass that as a dereference thing. Is that right? I mean, there should be no harm. Oh, mind you, the void star thing. by the same token, this guy could do exactly the same thing. And I guess it's just child, isn't it, really? I'll fix them up when I get told about it. So that'll fix that guy's pointer. And then, because we've actually fixed the pointer, this child pointer is not now stale. And it wasn't anyway, but I mean, we just could have done it a bit differently. So we just run it and just double check that we haven't actually screwed anything up there. Probably worth noting that at the end of this function, the syncDB, because this is the outer person, we don't need to ever need to touch this, actually, I don't think, because everybody should be fixing up the best parents. Right, so this never really needs to happen. I mean, we can let this happen. Basically, this thing here, this S pair, sorry, yeah, we don't need to. Right, we don't need to fix up the S parent because these people in here are all fixing up the S parents, so that this check is always should always be correct. Right, so that means that we take this out of the loop. The question now is, though, after we exit this loop, do we need to care about the S parent? I mean, we've got the S parent happening here, but this person, it should be fixed for here. And basically, we don't need to get out of this function having fixed up that S pointer, that S parent, because it's not passed into us. That's basically the thinking there. And then for this dude here, the project's block pointer, if anybody else later needs it, the way that these signposts work is that when you sync when you cycle the signpost file, the signposts get fixed up. So yeah, I reckon hopefully we should be alright. It's possible that I've completely just broken everything there, but we'll never know if we don't try it. Now, if I'm not mistaken, we would have succeeded with this run, but we shouldn't see the landmarks being fixed up. What we should see, however, is bitwise and P disappearing. Well, we've done that. We've gone through the function by now, so we can actually just look at the thing. Yeah, so they've gone. Bitwise and P have gone. And then there's the assets. So yeah, I think we haven't screwed up anything there. All looks fine to me. Which means that we can go on to do the next bit of the process. The process. It's the reorganize, isn't it? We definitely want to be going through all of the configured projects. That's a given. So we definitely want to enter this loop somehow. Yeah, we can only... We can only try and do this test, or this function, if there is an actual stored child that's an actual valid thing. So yeah, we do still need to do this. There's no way around that. Yeah, I think that this is as less as it needs to be, as it can be. So here we go. Don't do this. Instead of the actual assets loop, fixing up the landmarks. So all we're doing is what have we been given? We've got the generations. For child index, child count, what exactly is that supposed to be talking about? So region is produced into... I assume this is the right place to do this. Double check. So reorganize projects. Sync projects. So the generation is the main accumulator. This is the person that we want to be actually talking about. Pair with the child index and the S child. Oh, I see. So it does the stuff and then it breaks. So it's found the right person. It goes through this process. So because the result is true. Breaks out and returns the result. Okay. So yeah, I think this is the right thing to do. So it's accumulating the people that we need to skip past. So yeah, essentially what we're doing is we're talking about we're talking about moving this so that it occurs before this entire block. Yeah, it's also for each write out the landmarks. For this. By however many. Yeah, it's the entry count, isn't it? Right, so for each gen. and then write out the rest of the landmarks. And the generations that we're talking about are the ones that are in this, isn't it? Right. Because we're moving this. Like, that's going to be the lesser of them, potentially, because it's only one project. Yeah, I think that's correct. This arc. Just go and grab the delete project interior person. Oh, it's basically this actually. Determine project landmark range. So taking the asset and the arc. And the arc in this case is the DB project index, which is a bit sketchy, isn't it? Local arc, main arc. let's do a determine generation landmarks range. I think I might like to do it also so that this guy can use it. Basically to save it having to do a particular test, isn't it? Where is that going to be? Determine project landmarks range. It's happening there. How is this knowing? Yeah, it's just this test actually. Right, because if you're actually constraining this to the entire, constraining it just to the generation, you would save yourself having to do this test. You would still need to increment that. There's local arc. So that's wanting to talk about local arc as opposed to this arc, which is what I sort of was about to do here. Oh, there is no this arc, is there? Because this is getting deleted. So that's probably why this is happening there. It's only got the local arc to use, I think is what the deal is there. So yeah, what's our determine project landmarks range? Alright, let's try it. J is less than this arc is what I'm kind of talking about, isn't it? of the generation index. Just call it gen index. I mean, clearly the first one is just going to be the first oh, actually, j equals 0. Well, it doesn't matter, does it? Because I guess if there's no... Yeah, because when I do this right from byte to pointer thing as well, remember? So it doesn't matter if there's... if there's no entries in a particular generation. Because it'll go through this, but this loop won't happen. It'll come around to here, and then if it ever needs to actually write something, then it will actually write what it needs to write, if you know what I mean, when it gets there. Yeah, so the landmark range is going to be the, what is it, determine project landmarks range when using the asset. And so we've got the ACK there as well, have we? DB project index. Oh, we need to get the first landmark, yeah. Where are we talking about that? I think we were just talking about that further up. Well, I mean, we could just do it here, can't we? Doesn't matter. Yeah, so it's not a deletion count in this case. It's actually it's actually one of these. Right, so we do that for this, and then having done that, yeah, it's this same dude, right from byte to pointer. Now, then instead of doing this and this, I think we just do a couple of loops. Do we not? I mean, this is sort of where I was hoping to use the generation thing, actually. You know, if I get all the landmarks that are in a particular generation, then what you can do is you do your first write from byte to pointer, like right here. Actually, it's coming in as bytes through pointer, isn't it? No. We initialize it. Right. So that'll write us up to this person. Shouldn't it? Don't call that right. Then you need to do a loop over this. Ah, yeah. So as well as doing the loop over this, you also do need to do the loop over the local ACK. Wherever that is. Where is that guy? This person. Right, these are these product indices. So is there any way we can just like pull this stuff out? Because what is this actually trying to do for us? I think it's trying to... It's trying to give us the generation pointer and tell us how many people in that generation to actually operate on, isn't it? So let's pull that out. Actually, now that I think about it, the accumulators sort of want to be containing this, don't they? Right. So rather than this just being an entries in generation count, maybe it also has the first landmark, maybe. I'm not sure. We also need to add the index to the main ACK, don't we? Don't we need to do that over here as well? Ah, yeah. So, yeah, I beg your pardon. Index is that, and then if the gen index is less, sorry. This, what is it? Gen index. Oh, okay. Gen index is less than the main ACK dot count, is it? Do we have the main ACK? Well, it's a G, isn't it? Yeah. Let's yeah, I do feel like I wanted to be. Might as well just loft this out. So taking the DB assets, isn't it? So we can actually talk about that in the determined period landmarks range. It wants to take somewhere to store the DB product index. And it wants to take the is that right? No, it's not that. It's the landmark range. That's what we want. Does that sound right? Get first landmark and range of projects. So yeah, it does seem like we do need to set the DB product index. But it also wants to take the product generation so it can modify that index. This ACK. Yeah, basically my thing here is I want to be doing only one thing, so I do need to have a loop. Don't I? this out counts. What do I actually want to be pulling out of this? I feel like I want to be pulling out this, right? So if we're doing that, where was that? Yeah, I didn't know if that's what I wanted, was it? Yeah, I guess gen index is actually what I want to be talking, isn't it? Right, so we need this arc. So there's our result. This landmark count, do we care about that landmark count? I don't think we do we? Oh yeah, we do. Well, I mean, this is kind of the landmark range, actually, isn't it? Yeah, if we haven't said that, if we don't have a result at this point, the result is equal to locate first landmark, and the desks first. Yeah, that is, should be that. So what was it taking? Probably the main ACK, wasn't it? So you got the asset, the main ACK, this ACK, the gen index, and the destination range. Right. So all that's going to happen. Yeah, so actually we don't want to be writing from byte to this landmark, we want to be writing to the local ACK landmark, don't we? Right, so these are our ranges that we're talking about. We're writing from there to there. And then what you want to say is what are we up to? Asset index, best guess landmark index. This range first. Well, actually, we could do this a little bit differently, couldn't we? Right. We've already got this range. Right, so all we're doing is we're looping over this range. and we're saying well, this ACK, isn't it? Or local ACK. I guess we need to do the test, do we? If the generator is less than the local ACK. Don't count. Right. So we do that over that range. And then we do the same loop just over the local landmark index, local ACK. We don't need to do this test on this ACK because we know we're going to be below there. Oh, wait a minute. We've got a new landmark. So, sorry, that should have been like this. Did I write the new landmark? Yeah. New landmark project index plus equal to this ACK interesting generations at index. Right. And then having done that, you want to write out everybody else in this generation. Which we don't know, do we? we really need to say yeah, we just don't know, do we? We don't know what the range is of this generation. Also, I think this, I might just rename this from get to determine. Alright, this is using the determine function, isn't it? Yeah. Trust me on this one. Basically, the idea is that, because it's not only talking about one project, it's talking about what could be like multiple children of a project. Yeah, I mean, I guess we could just hack this a little bit. Right, we don't really need a determine landmarks range. All these pluses. Yeah, I guess it doesn't really make sense to talk about using the actual running landmark index as the index for these people, because they're going to fall out of sync, aren't they? We also do this the other way round, so we've got that happening. So we've got the two indices getting indexed, getting incremented, before finally incrementing the actual dude. Well, what do you call these? Tail landmarks. Oh yeah, we haven't got that first landmark pulled out. It's not such a big deal, but very nice to have. Then where this is getting cut, where this is getting called, we're not calling it. Oh, is it this person is calling it? Locates. Yeah, it is. Okay, fine. So we don't need to bother doing what I was about to do. I mean, you just write it out, don't you? Yeah, I think you do just write it straight out. Oh, sorry. Yeah. Right. F right and increment that byte just so it's kind of somewhat right. Yeah, and then I think that's it, isn't it? So, I think, yeah, if I'm not mistaken, that should be doing all the stuff that we needed to do. So I guess let's try it. Yeah, let's try it. If it doesn't work, it doesn't work. Well, yeah, we need bitwise to get generated. And P. But I guess the key thing is that we get this bitwise asset popping into here. So now let's close, remove bitwise, run it again, and see if we, well, crash. So we're crashing. Delete predator top level, delete landmarks of predator and children. So yeah, we will have hit this after doing the relocate. Won't we? Delete landmarks of origin to interior. So let's walk through it, see what's happening. So we're looking at so we've encountered bitwise. So yeah, our S child should be bitwise, shouldn't it? I think. Yeah. With the child count of 1. So we're basically looking to reorganize risky so that it comes before bitwise and P. That's what we're trying to do. So we found risky, so yep, we're going to enter this. So we've got 1, 3, 2 in risky. Yeah, sounds bang on. How about local ACK? Got 2 and 1, so we've got 2 people in generation 0, 1 person in generation 1. Yeah, that's right as well. Let's go to right to there. Okay, and I think that was correct. Now, there's 11 assets to be talking about. Ah, yeah, so I think I see, actually. It's going to write out this, but we might not enter this loop. Is that right? Generation 1 index 0 for this is... oh yeah, it could be right actually. So that's the first landmark for us. Now how about this range? Oh, we need to dereference dest, don't we? Is that right? Well, maybe not. I guess this isn't necessarily what I want to be talking about. Dest first. Really? Oh, hold on a second. So gen index is coming as 0. So we're talking about generation 0. Index 1. Actually, that might be right. Yeah, that is right. Isn't it? There's 1 there. J will be 0. But we offset this by the main index, so that I think is right. And now it's trying to determine the project landmarks range of generation 0, index 1. Oh yeah, this is right as well, actually. Yeah, it is. Now, the thing is, though, the first landmark. Yeah, I think that he's going to set it to the wrong thing, isn't it? Is that right? Yeah, I think it's if the 0th generation project doesn't have any landmarks, this is busted. So we need to do another check here. I think if there's any landmark range at all, if there's no result and the landmark range length is greater than 0, then we can go ahead and do this. Try it. Not 100% sure, but I think that might be something to do with it. And then here, whether or not the length is 0, it doesn't matter, we can increment what we need to increment. Oh, we're passing the wrong app to this person, aren't we? Yeah, that's another bug. we passing that by address that I want to? I guess it's just because we initialize it in this function. Yeah. And then we like to just make it take things by pointer to it. So have I written anything? Yeah, I have written some stuff by now. Let's build again, just to make sure that I did actually build it. Oh, yeah, we need to get bitwise in. So let's just step into this again and just watch it, what it does. So we just did this other check for this person here. So we're looking at gen index. Or rather, we're looking at this, aren't we? Entries in gen index. Okay, so it has one entry in gen index. 0. But we're looking at bitwise. Right, which previously it didn't have any landmarks for the gen 0 person. So yeah, we don't pass that. Return the results. Which is 0. Now, this rate, yeah, I guess we're not going to enter this loop, so we should be safe from dereferencing this that doesn't exist. Let's step into this. I think this also won't have any entries for it, strangely enough. Yeah. So, yeah, unfortunately we've got this though, haven't we? So I suppose we need to actually check that, don't we? Right, because if I try and print that, it's just going to be at null null. Yeah, let's make it check that. And then I think these guys should also be safe because this range.length is nothing, isn't it? Similarly, local range lot length would just, well, Yeah, that's nothing. So these loops won't enter. And then it's going to try and locate the first asset of this, and then if there is even an asset count at all, a landmark count, then it'll do that. So yeah, I think maybe we should be safe for everything else, apart from this call. And I mean, for all that matter. Only if there's a localized landmark would we be able to actually do this. Let's try again. I hope my pointers will, my breakpoints are going to remain, but we never know. It's always a bit of a look at the draw. All right, so got it. So if we've got a local landmark, which we don't have, I don't think. Yep, perfect. So now what do we got? What do we got? So this guy's generation 1. Right, so the very first landmark, considering that running a landmark index is going to be a 0, right, is a generation 1, which isn't the same as what the generation that we're talking about. So this ain't going to pass this test. So we should write out sod all. Perfect. Next generation. So here we go. We have some landmarks. Now, yeah, it could be the first landmark is 383 as well, because Handmade Heroes landmarks will be before it. Oh, we're getting in again, are we? Why are we getting in again? Because there's 3. What are we trying to determine here? Product generations, gen index, landmark range depth, the gen index, the main ACK and the this ACK. I mean, hopefully this is talking about risky. Let's just see if it could be. Determine that this landmark. So yeah, I think that is risky. Whereas the local ACK is going to be people like Bitwise and P. So yeah, okay. Let's go along with it. Alright, it's not a landmark. Yeah, just result. Generation 1, index 5. So that only did 1. So yeah, that would have been bitwise. let's have a look at our ranges. So that can't be right. What does that think it's trying to do? This range, local arc range, this arc, local arc. Ah, right. Yeah, because they're both only adding... Yeah, I see. So in this test here, yeah, in this thing, they're only adding the main arc. So it would actually need, so the guy who's coming after us would actually need to add in our edges and index, gen index as well. But I think I just heard Casey go live, so I think I'm going to call it. I think I know what the problem is there. Make the following. Is that right? I mean, well, it's kind of like, it's making this actually, isn't it? It's making this. Yeah, that's basically what we need to do. But yeah, we'll pick that up next time. So, thank you very much, Hazen Heroines, for being here, for being beautiful and fantastic, and for being determined. Until next time, farewell for now.